thought we'd try another application of integration. This will be part 3. Find the area enclosed by the functions. This could also read find the area between, find the area captured, etc. So our first function is f of x. Our first function is f of x is equal to x squared minus 4x. Our second function is g of x is equal to 2x. I don't know if you can visualize these in your mind. I think that they're kind of reasonable to draw out in your mind because I think these are the details that we need are not too bad. So this one looks like this. Let's look at f of x first. I think f of x looks like this. If we factor f of x out, we can get x times x minus 4 equals 0. So x is 0 and x is 4. So that gives us x is 0 and maybe x is 4 out here. Something like this. We know that this is a minimum parabola, so it's going to take on, it's going to look something like that, I guess. Okay. So if you're by the x, I'm going to extend this out a little bit like this. And we're going to say that this is our f of x function. So there's f of x right there. And here's our second function, and it's y equals 2x. So it's a direct variation, isn't it? And it will look something like this. It's like that. So hopefully we can get an idea of the area that we're looking for, and the area we're looking for that's captured is the area here, isn't it? So this area right here. Right. So we're trying to figure out what this area is in here. So I guess my next question now is if this is g of x down here, isn't it? This is g of x. First off, where do they meet? So where do they intersect? So I guess first thing is do f of x and g of x intersect? That is, where are they the same? So if we're trying to make them the same, I'm going to take my f of x, which is x squared minus 4x, and I'm going to set it equal to 2x because that's what I want to know. When are they the same? Going to add negative 2x to both sides, right? So I'm going to solve this. Negative 2x here. We're going to get x squared minus 6x equals 0. So I'm going to factor this out and say, you know what? This is the same as x times x minus 6. So where do they meet? Well, hopefully we knew that this was here. X is 0 here. It happens to be the point 0, 0. But what I'm really concerned about is the x value, because that's going to set up that interval. And the x value of this point right here is the point, if this is the point 6 something. If you want, you can figure out 6 what, but I frankly don't care because I don't think that's the question that we're being asked. The next question we have to ask ourselves is which function is over top of the other one? Because if this is an f of x here, and this is your g of x doing something like this down here, and you want the area in between, what you want is f of x minus g of x. So you want to know which function is on top. How would you figure that out? Well, on the interval, what I would do is I would just pick a number between 0 and 6, plug it into both equations, and see which equation comes up higher, and it will be 2x. So what I think that we're looking for here is the integral from 0 to 6 of 2x, right? Of 2x minus this function here, minus this function. So minus this function, which is x squared minus 4x, the whole thing dx, right? Okay. Can simplify this out a little bit, I think, can't we? This becomes negative x squared. This becomes positive 4x, doesn't it? I'm just stripping the negative sign. 4x, and then this 2x was here, wasn't it? Now add them. I'm just going to rewrite the interval. You're going to rewrite the antiderivative, the definite integral here, 0 to 6, and it would be 6x minus x squared dx. Isn't that right? Dx. From here, we really have the battle is actually won right here. So just to keep it in mind, what did I do first? First thing I did was tried to graph the functions. I asked myself if I could graph them relatively easily, and these ones were pretty graphable. So I graphed them, tried to figure out I set the equations equal to one another to find out where they intersected, because where they intersect, those areas in between the intersections are enclosed areas. So that's what we're looking for here. Now I'm going to go ahead and integrate, right? So finally we get to the good part. We're going to integrate here. We're going to integrate and integrate here. So what I'm going to do is integrate this, and I'm going to say is equal to, right, it would be 6x squared over 2, right, because this is the first power, so it's 1 plus 1 over 1 plus 1 minus, this is x squared, so you increase this by 1, so it's x cubed, and put it over this value here as evaluated from 0 to 6. I'm going to go ahead and simplify this a little bit, if you don't mind. I'm going to simplify this a little bit, and this will be the same as, right, 6 over 2 is 3, so 3x squared minus x cubed over 3 as evaluated from 0 to 6. Okay, now all we have to do is just apply the fundamental theorem of calculus. The fundamental theorem of calculus promises that this is true, so we take FTC here. It promises that the area is equal to f of b minus, sorry, it's not true, f of b minus f of a is the area. So I'm going to set that up, if you don't mind. And so it's going to be f of 6, isn't it? Minus, this is a 6. F of 6 minus f of 0. And f of 6 would look like this. It would look like 3 times 6 squared, right? 6 squared minus 6 to the third power is 216. 216 over 3, and I happen to know, right, these rules from 7th grade come in handy. Happen to know that this number 216 is divisible by 3. How do I know that? Because 2 plus 1 is 3, 3 plus 6 is 9. 9 is divisible by 3, so is this number. So I did a little bit of math, and I figured out that this simplified to 72. So this is 72. 72. Also know that 6 squared is 36. I guess I just keep writing this out a little bit. Is 36. So 3 times 36, which happens to be 108. But I did a little bit of math on the side there. Minus this 72. That's f of 6. F of 0 is 0, so it's equal to 36. So, which is the area. That's what I'm banking on here. I'm going to go ahead back out and test this, if you don't mind. And the way I'm going to test this, I'm at my my TI Nspire CAS calculator. I'm going to go to Insert. So for you, it would just be the home screen. So I'm at the home screen. I choose Calculator. From there, I go to Menu. In your menu, you'll see Calculus. In Calculus, you'll go down to Integral. And this can be used as the indefinite or definite integral. And in this case, it's the definite integral. So it's 0 to 6. 0 to 6. And I'm just going to put in what the value was. And it was, what was it? It was 6x, wasn't it? 6x minus 4x. It's the, right? This is the non-integrated form because I'm taking it here, right? And then hit enter, and please let it be 36. Yay! Yeah, yes. So, okay. I think this is the third one. I think I might do one more, but then I'm going to be done with this for area under the curve, and we can move on to more difficult applications. But hopefully you're taking good notes, and you're going to see this. You're going to see this stuff. So, good for you.